So today we're going to start talking about properties of linear functions, and we're going to begin with the x and y intercepts. Now the y-intercept is something that you're probably familiar with coming in from pre-algebra, and maybe you talked about the x-intercept, but it wasn't really a focus. So we'll talk about both pretty in depth today. So the first thing is the definition. So the y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. So at where the graph of the line crosses the y-axis, that is considered the y-intercept. It's always going to be in the format of 0, y. That's because if you are on the y-axis, you wouldn't have moved left or right on x, and so x should be 0. With your x-intercept, it's the x-coordinate of the point where the graph intersects the x-axis. In this place, if we're on the x-axis, that means we didn't move up or down, and so the y-coordinate is always 0. So these are in the format of x, comma, 0. So the y will always be 0 here. So y-intercept, x is always 0, you have a y. X-intercept, y is 0, and you have an x. So whichever intercept you're talking about, that's the value you should have in the ordered pair. The other value should be 0. If I gave you the equation 3x minus 2y equals 6, which is in a standard form, then we would want to find the two intercepts. To begin with the y-intercept, we would want to replace x with 0. We know at the y-axis, x is 0. So if I substituted in 0 for x, that's going to be 3 times 0 minus 2y equals 6. Well, 3 times 0 is 0. So that term, in essence, is gone. It reduced to 0, which doesn't have an impact. So I have this little hand here covering up because when I do these, I think, okay, well, x is 0, so I can kind of ignore the x term and deal with what's left, which is going to be this negative 2y equals 6. So if I'm dealing with negative 2y equals 6, then I would divide by negative 2, and y would be negative 3. That puts the ordered pair at 0, negative 3, because I use 0 for x, and the y is negative 3. Kind of the same idea with the x-intercept. If y is 0, because I'm on the x-axis, I could go ahead and substitute in a 0 for y. It's not a big deal to do that. That's going to make it 0, which is going to leave us with 3x equals 6. Since the whole y term goes to 0, I could kind of pretend it's not there, so I could kind of put my finger or my hand over that term and see what's left in the equation, which in this case is 3x equals 6. So if I then divide by 3, I should find that x is 2. So our x-intercept is at 2, 0, when y is 0 and x is 2. If I wanted to graph that, then 0, negative 3 would be here. 2, 0 would be here. And I could then connect those and show the line of the equation here. So this is one way to graph a line, is to know if you know 2 points and you know it's linear, which we know this one's linear, it has an x and a y, no exponents, then all I need is 2 points. Go ahead and see if you can find the y and x intercepts for this one. So for your y-intercept, you would be replacing x with 0. So that would be negative 5 times 0, which is just going to go to 0. You can just ignore it. So you're left with positive 6y equals 60. So if you divide by 6, you should get y equals 10. So this one would be at 0, 10. If I go to graph that on the y-axis, I should be at 10. So y-intercepts are on the y-axis, x are on the x-axis, and so for your x-intercept, you would be replacing y with 0. That's going to make this term go to 0, and you don't really need to worry about it. And then if you divide by negative 5, you should get x to be negative 12. That would put the ordered pair at negative 12, 0, which would be here on the x-axis. And then based on those 2 points, you could draw the line of the graph. So if the point 5, 0 is on a graph, that means x is 5 when y is 0. If x is 5 and y is 0, that would not make it a y-intercept. This would be an x-intercept. It does not move up or down. It does move to the right 5 spaces from the origin, which would leave it on the x-axis. So this is an x-intercept. So this could apply also to a word problem. So here in the Sandia Peak Tramway in Albuquerque, New Mexico, travels a distance of about 4,500 meters to the top of the Sandia Peak. Its speed is 300 meters per minute. The function f of x is equal to 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. Find and interpret the meaning of the x and y intercepts. Now this doesn't even have a y per se, but remember that f of x is the output based on x, and so f of x is another way of showing y. So if we wanted to find the y-intercept, we would replace x with 0, so we would have f of 0 equals 4,500 minus 300 times 0. That's not going to do anything, so f of 0 would just be 4,500. If you're looking at your graph, you can see your y-intercept there at 4,500. That is going to be the place where the tram begins at the top of the peak. So that's the top of the peak, and then it would travel down. So as you're trying to figure out the x-intercept, you would need to replace f of x with 0. So the whole f of x becomes 0, which means now our equation is equal to 0 equals 4,500 minus 300x. So if you add 300x so that it's on the opposite side of the constant, you'd have 300x equals 4,500. And then if you divide by 300, you should find that x equals 15. So your x-intercept here is 15, 0. This is going to be the time it takes to descend from the top of the peak. So 4,500 is the top of the mountain, and 15, 0, your x-intercept is the time it takes to reach the bottom. So these are very similar to what we started with, except they're not in standard form, meaning that they're not already solved where x and y are on the same side of equal and there's no fractions remaining. We'll talk more about standard form later, but the process would be the same. If I'm looking for the x-intercept, then I know y is 0. And if I'm looking for the y-intercept, then I know x is 0. So let's start with the y-intercept. If I have 1/2 y equals 3 minus 3/4 times 0, that goes to 0, so I don't have to worry about it. So I have 1/2 y equals 3. Well, if I multiply by the reciprocal, which would be 2, so I can multiply by 2 over 1, 2 over 1, then that would give me y equals 6. So our y-intercept would be at 0, 6. X is 0, y is 6. And I could graph that on my y-axis there. If I am looking for the x-intercept when y is 0, then I would have to do 1/2 of 0 equals 3 minus 3/4 x. Now here we want to be careful. Yes, this term is gone, but because it's the only thing left on that side of the equation, I do need to keep it. But I can also move the 3/4 x. I can add 3/4 x to both sides. That would move the x and the constant into opposite sides, so I could then solve it. So if I have 3/4 x equals 3, I'll multiply by that reciprocal of 4/3, and that's going to be 12 over 3, so x is 4. So the x-intercept would be at 4, 0, which would be here. And then I could graph the line. Go ahead and try this one. To find the y-intercept, so we'll start with the y. That means our x would be 0, so we would have 18y equals 12 times 0. That's going to be gone, plus 108. So it mathematically won't matter if we're adding a 0. Then we'll divide by 18, and y would equal, so y would equal 6. So this one would be at 0, 6, which would be here on the graph. For the x-intercept, we would say 18 times 0 is going to equal 12x plus 108. So now we have 0 equals 12x plus 108. You either need to move the 12x or move the 108. This time I'm going to move the 108 since the x is a positive coefficient. We'll just leave it positive. It wouldn't matter. You're going to get the same value. So divide by 12, and then if you have 108 divided by 12, you should get negative 9. So x here is negative 9, or negative 9, 0 as an ordered pair, which would put it here. So this scale is counting by 2s, and so it's going to be halfway between negative 8 and negative 10, which is the edge of the graph. And then there would be the line of the graph. So if a line intersects the y-axis at a point AB, so we're talking about the y-axis, so anywhere along this line, is A 0 or is B 0? And so if you're thinking about, if you're staying on the y-axis, then that means your x value has to be 0. In this case, if the ordered pair is AB, then that means that it would be A is 0. Because A is representing the x value, and then the x value has to be 0 to stay on the y-axis. So that's kind of a fairly quick overview of intercepts, and we will continue working on those Friday with moving towards slope and writing equations.